I know, terrible place to end the recording. But this video is going to summarize what we've done for 4 different videos, starting with the simple linear model. And my guess is this is going to be the video you're actually going to want to come back to and reference and take little screenshots of. So here's our 4 models. We have a linear model where it's just y and x. This is what we've been doing for a long time, and you probably even did this in your intro class. Now, if we log x, I like to call that a log model. That's not consistent wording. Other people use log model to describe all of these, or log linear. That's what I call it when I log y but not x, and that terminology is not consistent. And then log where we've logged both of them. A mathematician would get confused because they'd say these are all linear models because the math definition of linear is like that. But here with our basic model, if we want to interpret the slope, then we say as x increases, y goes up by beta 1. That's something that you should feel familiar with for several months now. But if we switch to a log model, because we're logging x, now we want to talk about a percentage change. As x goes up by some percent, then y goes up by this much. And that's an additive effect on y because y is not being logged. Now this is confusing because that 3%, you take 3 over 100 to get 0.03, which means it's 1.03. That's how you get a 3% increase. But knowing that those percentage increases are a multiplicative effect is a really important deal. If we had logged y, then we would talk about x increasing by 1, but y would increase by this amount, which is again a percentage effect. If x and y are both logged, then x goes up by a percentage effect, y goes up by a percentage effect. Now, I've tried to leave these equations as all very generic as possible. We could redo them with a specific log. For example, log base 10. We like 10 because we count in tens, or possibly e because e is also a common base, especially in R. You'll see me do a lot of base e, although there is a homework that's based off of log 10 and actually asks for that specifically. Oh, I forgot 10. It's not so cool for the formulas to change all magically if I forget to change one. Now, a lot of this notation is because this 3% is 0.03, and I'm trying to emphasize that. If you were comfortable with that and you didn't get confused, we could change how these look, because now we don't need to talk about 1 minus this as a percentage, or we don't need to talk about 1 minus or 1 plus the p, because p is what we're multiplying by, 1.03 for a 3% increase. So you just take the log of that 1.03, or p to the beta 1 here. And sometimes in books, that's the way you'll see this written or described. But I think I've found students have a hard time remembering 1.03 is how you do a 3% increase. So if that first set of equations is what makes sense to you, then go with that. Otherwise, I think it might make more sense if we actually go through a data set and look at it, and then you'll be able to see some of these relationships.